Hello, my name is Touma. My ID is 6359553, and this is the lab project 6 from group 2.
Hi, I am Hannah Contramaestre. My group number is number 2. Panther ID is 6117264.
Hello, my name is Mohammed Alsabbaghe. This is a submission for lab number 6. My ID number is 5731743.
Okay, so basically I'm doing activity number 1 with Muhammad. And so for this activity, we basically put the R that's equal to 220 and then that C1 is equal to 0.1. I had to type it out because my tablet's acting up for some reason. The pen is being annoying. Anyways, Mohammed's basically doing the drawing and the graphs, and I'm basically just explaining the results. So for the RC circuit of this kind, it has a phase shift that's given by theta is equal to tangent to the -1 times WRC, which you can see right here.
Hello, my name is Mohammed. I was responsible for doing the graphs of this lab, lab number 6. Basically, just drew it out. This. And over here for the...
For activity 2, I had to sweep the frequency for the different ranges of hearts that you can see on the screen using the 4 filters that are presented, and I had to classify each one. For this, I used the boat plot. And basically, the objective of this activity is to determine how the graphs change based on the hearts and the circuits that are presented, and also what does it mean with each classification, and how does the different parts of the circuits affect it. Here are the 4 circuits that were requested, each one with a respective boat plot, and I also used the AC suite component in the multisim to be able to graph the 3 different ranges of hearts, and that way be able to analyze it and determine which classification will they fall into. I determined that the first circuit had a low pass filter. This is because doing some calculations based on the graphs that are presented, I could determine that while W was 0, the V0 was 1, and while the W was infinite, the V0 was 0, which is basically means that this graph is low pass filter. Same as before, I calculated each graph, determining that in this case, the W0 was equal to the V0 0 as well. And while W was infinite, V0 was 1. So this means that it's actually the opposite of the previous one. So it's actually a high pass filter. Circuit C ended up being the same as the first one. So it's a low pass filter. And last but not least, for circuit D, it was similar to circuit B, so it's also high pass filter. The conclusion that I got from all these graphs and calculations is that the order of the components in the output is what determines if it's going to be high or low pass filtering. Because that was the difference between each example and if it ended up being a low or high.